Mariner. NASA designed and built 10 robotic interplanetary probes named Mariner to explore the inner solar system. Mariner 3 and 4 were the first of this series to be sent to Mars, and were intended to conduct the first flyby scientific observations of the planet. Mariner 3 was launched on November 5, 1964, but the craft stopped responding due to an equipment failure and its batteries ran out of power. 3 weeks later, on November 28th, Mariner 4 was deployed and became the first successful flyby of the planet Mars. It transmitted 21 photos of Mars, the first ever taken at close range, revealing a heavily cratered surface and no signs of liquid water or vegetation. Mariner 6 was launched on February 24, 1969, followed by Mariner 7 on March 21st of that same year. They flew over the equator and southern hemisphere of the planet Mars and captured 201 images altogether, covering about 20% of the Martian surface. Atmospheric studies by the craft confirmed that Mars had a thin carbon dioxide-rich atmosphere and a dry, cratered landscape, reinforcing the planet's inhospitality to life. Mariner 8 and 9 were the third pair of twins designed to study Mars. Mariner 8 was lost in a launch failure, but Mariner 9 was successfully deployed on May 30, 1971, and eventually became the first spacecraft to orbit Mars. At the time of arrival, Mars was engulfed in a global dust storm, but once it cleared, Mariner 9 mapped 85% of the planet's surface, discovering Olympus Mons, the largest volcano in the solar system, and Valles Marineris, a vast canyon system. It also provided the first detailed images of Phobos and Deimos, which are Mars's two moons. Viking. NASA's Viking program consisted of 2 spacecraft, Viking 1 and Viking 2, both equipped with an orbiter for taking photos and a lander for studying the surface. Viking 1 launched on August 20th, 1975, and the lander touched down on Mars on July 20th, 1976, making it the first successful Mars lander in history. Viking 2 launched on September 9th, 1975, and landed safely on September 3rd, 1976. The Viking landers conducted biological experiments designed to determine whether life existed in the Martian soil. One experiment turned positive, but the result was later determined to be faulty due to inorganic soil. Both landers deduced that Mars's surface is dry, rocky, and covered in iron-rich dust, and that the atmosphere is 95% carbon dioxide, with insufficient pressure to support liquid water. However, the 52,000 images returned by the 2 orbiters flipped our ideas of water on Mars on their heads. The images showed that eons ago, floods of water traveled thousands of kilometers, carving deep valleys and eroding grooves into rocks along its path. These regions, called chaotic terrain, have appearances that suggest an amount of water estimated to be around 10,000 times the Mississippi River. If there truly was this much water, how exactly did it just seemingly up and vanish? Pathfinder. Mars Pathfinder was a NASA mission that launched on December 4th, 1996, and landed on Mars on July 4th, 1997. Pathfinder used an innovative method of directly entering the Martian atmosphere, assisted by a parachute to slow its descent through the thin Martian atmosphere and a giant system of airbags to cushion the impact. It was the first time this airbag technique had been used. Once the lander deployed its pedals, it revealed Sojourner, a 6-wheeled rover equipped with cameras and a spectrometer to analyze Martian rocks and soil. By bombarding the Martian surface with alpha particles and measuring the resulting energy emissions, scientists determined the elemental composition of several different named rocks. One rock, called Yogi, had a basaltic composition, but harbored weathering patterns suggesting it had been altered by liquid water. Ultimately, the Pathfinder mission sent 16,500 lander images, 550 rover images, extensive atmospheric data, and more than 15 chemical analyses of rocks and soil before communication was lost on September 27, 1997. The final conclusion of the mission and its findings suggested that Mars was at one time in its past warm and wet. NASA's 2001 Mars Odyssey was launched on April 7, 2001, and entered orbit around 6 months later on October 24th. It spent about 3 months using aerodynamic drag from the upper reaches of the Martian atmosphere to gradually slow down and reduce and circularize its orbit. Once Odyssey fully stabilized, the spacecraft's gamma-ray spectrometer detected large amounts of hydrogen, a sign that there must be ice lying within a meter of the planet's surface. It also mapped the distribution of water below the shallow surface, unveiling deposits of water ice near the surface of equatorial regions previously believed to be dry. This was a groundbreaking discovery, as it provided the first direct evidence of near-surface water on Mars. Originally designed for a 4-year mission, Odyssey has remained functional for over 2 decades and continues to conduct important experiments. It has completed over 100,000 orbits around Mars, making it the longest operating spacecraft in orbit around another planet. Using instruments like Themis, Odyssey captures infrared images that help scientists identify surface materials and monitor Martian weather patterns. Additionally, its MARI measures cosmic radiation levels that astronauts would experience on the Martian surface, providing NASA with data for developing shielding strategies for future crewed missions. Spirit. NASA's Spirit was a solar-powered, 6-wheeled robotic rover that launched on June 10, 2003, and landed on Mars on January 4, 2004, using the same technology that allowed the Mars Pathfinder to land safely. Spirit landed inside Gusev Crater, a landing site that was chosen because it was suspected to have once held ancient water-deposited sediments and discovered sulfate-rich deposits, including bright, silica-rich soil. Using its robotic arm and mini-TES, it confirmed that these deposits were likely formed in a hydrothermal environment, suggesting the existence of past hot springs or fumaroles and indicating that at least some regions of the planet had once been habitable. In May 2009, Spirit became stuck in soft soil at a site later named Troy. Engineers attempted for months to free the rover, but it was unable to regain traction. By early 2010, NASA shifted Spirit's mission to a stationary science platform, using it to monitor seasonal changes and study the planet's interior by detecting tiny wobbles in Mars's rotation. However, as Martian winter set in, Spirit's solar panels could no longer generate enough power to keep the rover's electronics warm, and despite repeated attempts to re-establish connection, NASA declared the mission over on May 25, 2011. Opportunity. 3 weeks after Spirit touched down on the planet, Opportunity landed on the Meridiani Planum on January 25, 2004. Specifically, it came to rest inside Eagle Crater, and within weeks of landing, the rover made a groundbreaking discovery. It found layered sedimentary rocks that contained hematite, an iron oxide mineral that typically forms in water. These blueberry-like hematite spheres were the first direct evidence that liquid water had once existed on Mars's surface. Nearby, Opportunity found other rock formations whose chemical composition suggested that Meridiani Planum had once been home to acidic, salty water. After traveling 21 kilometers and visiting various significant geological sites, Opportunity reached Endeavour Crater in August 2011, where it found clay minerals, the strongest evidence yet that at one point Mars actually had water that could have harbored life. On June 10, 2018, a planetary dust storm caused Opportunity to cease communications. Engineers hoped it would reboot once the skies cleared, but it never responded, suggesting either a catastrophic equipment failure or that a thick layer of dust coated its solar panels. After 14 years and 138 days of groundbreaking exploration, NASA officially declared Opportunity's mission over on February 13, 2019. Mars Reconnaissance Orbiter. NASA's MRO launched on August 12, 2005, entered orbit on March 10, 2006, and has been operating continuously for over 18 years. The orbiter is equipped with the HiRISE, which is the most powerful camera ever sent beyond Earth, capable of capturing images at a resolution of 25 centimeters per pixel. It also carries the XRISM, which can detect minerals on the Martian surface. Both the HiRISE and the XRISM worked in tandem to reveal ancient river deltas, lake beds, and mineral deposits that could only have been able to form in the presence of standing water. The orbiter also detected massive underground reservoirs of frozen water, including a deposit at Utopia Planitia that holds as much water as Lake Superior. For the prospect of future manned missions, astronauts could potentially utilize this source of ice as a resource. Beyond its role in planetary science, MRO relays communication from Mars rovers and landers via ultra-high-frequency radio, then transmits the data to Earth using its high-gain antenna, where NASA receives and processes the signals. Using this method, massive amounts of data has been sent back to Earth through every major rover and lander since 2006. Phoenix. Phoenix was a space probe that launched on August 4, 2007, and landed in the northern polar region of Mars on May 25, 2008. It touched down in Vastitas Borealis, a broad plain where orbiters had previously detected subsurface ice deposits. During its descent, the MRO's HiRISE camera photographed Phoenix suspended from its parachute, the first time one spacecraft photographed another during a planetary landing. Just days into the mission, Phoenix's robotic arm uncovered water ice beneath the surface, providing direct physical evidence of water on Mars. Examining the surrounding soil, Phoenix discovered traces of the chemical perchlorate, a possible energy source for microbes and a potentially valuable future resource for human explorers. Then, the craft performed wet chemistry experiments that detected nutrients such as magnesium, sodium, potassium, and chloride, all of which are essential for plant life. While this does not confirm the presence of life, it suggests that if liquid water existed in the past, Mars may have had habitable conditions for microbial life. Lastly, Phoenix also carried a meteorological station that detected ice crystals falling from the atmosphere, confirming an active water cycle on Mars, where ice can form in the air and fall to the surface. The lander completed its mission in August 2008, and after engineers were unable to recontact the craft due to the Martian winter reducing available solar power, the mission concluded. Curiosity. Curiosity is a car-sized Mars rover that was the largest and most advanced robotic explorer ever sent to Mars when it launched on November 26, 2011. It landed on August 6, 2012 in Aeolus Palus, a flat region inside Gale Crater, which is an impact basin that holds a geological geological records stretching back billions of years. The site was chosen because of its proximity to Mount Sharp, a towering peak of layered rock at the center of the crater, which scientists believed were hiding many of Mars's geological secrets. Curiosity is equipped with the SAM instrument suite, which is capable of separating individual gases from complex mixtures into molecular components. SAM studied rock samples from Gale Crater and identified sulfur-containing molecules and chlorobenzene preserved in 3.5 billion-year-old mudstone, hinting at the possibility that liquid water remained stable for thousands to millions of years. SAM also detected fixed nitrogen, a fundamental component of DNA, in the form of nitrates within Martian rock samples. While not direct evidence of life, these findings confirm that the building blocks of life were present on ancient Mars, and that any potential life forms could have thrived for many years. To celebrate the halfway point on Curiosity's planned 2-year mission on Mars, it hummed happy birthday to itself. However, this function was disabled after the first round in order to preserve battery life, and Curiosity's operations were extended indefinitely as it remained fully functional and continued making discoveries. As of uploading this video, Curiosity has been active on Mars for over 4,600 days. Mars 2020 was a mission that launched on July 30th, 2020, and housed the rover Perseverance and the helicopter Ingenuity. Perseverance landed on the Martian surface on February 18th, 2021, and was designed to explore Jezero Crater. It is equipped with several advanced scientific instruments that allow it to scrutinize the chemical composition of Martian rocks. At Wildcat Ridge, a rock formation located within Jezero's well-preserved sedimentary fan deposit, Perseverance used these instruments to uncover evidence for an ancient lake environment. Not only were these sediments likely deposited in a standing body of water, but they also continued to interact with water long after they were formed, potentially preserving possible precursors of past life. In July 2024, Perseverance made another significant discovery at a reddish rock formation named Chayava Falls, where it detected leopard spots, which are patterns that show more convincing indications of past microbial life. Attached to the belly of the Perseverance rover was the Ingenuity helicopter, a small, experimental aircraft that became the first powered, controlled flight on another planet. Ingenuity was designed as a technology demonstration, meant to test whether flight was possible in Mars's thin atmosphere, which has only 1% of Earth's atmospheric density. Ingenuity completed several successful flights, far more than initially planned, and operated on Mars for 1,071 total days, before sustaining serious damage to its rotor blades, causing NASA to retire the craft on January 25, 2024. Despite Ingenuity being discontinued, Perseverance continues to collect and cache rock samples for a future Mars sample return mission, which will bring them back to Earth for further analysis, potentially answering the question of whether life existed on Mars for good. Humans on Mars. Technology is rapidly developing, and the idea of sending humans to Mars has become closer and closer to reality. However, this doesn't come without its challenges. Mars's thin atmosphere provides minimal protection against cosmic rays and solar radiation, which long exposure to can cause health risks like cancer. Even with the MRO's support, communication between Earth and Mars is also a challenge, as delays can range from 5 to 20 minutes each way, meaning astronauts stationed on Mars have to be effectively self-reliant. Despite this, NASA and SpaceX are working hard to make putting humans on Mars a reality. NASA's first crewed mission to Mars is expected in the 2030s and would likely involve a 30-day surface stay. As part of their overall goal to reach and establish a significant presence on Mars, NASA is hosting Chapia, a series of year-long missions in which a small team of volunteers live in a 1,700 square foot 3D printed habitat at NASA's Johnson Space Center. The mission's efforts to mimic a real Mars mission include a 22-minute delay in communications, resources limitations, simulated equipment failures, and simulated spacewalks. These factors should hopefully reveal the psychological and physiological effects of long-duration space travel and long-term confinement under the terms required to survive on Mars. On the other hand, SpaceX is more ambitious and plans to send 1 million people to a fully habitable Mars by 2050. SpaceX's Mars plans center around the Starship spacecraft, a fully reusable rocket system designed for deep space travel, equipped with life support systems that can sustain a crew for the months-long journey to Mars. It can be refueled using local resources, such as Mars's latent water ice, to produce methane and oxygen propellant. With NASA and SpaceX's efforts, the dream of reaching Mars is no longer confined to science fiction.